Hey everybody, we are going to be talking about quadratic parts from standard form this time. So I want you to remember that your A value right here, okay, that tells you if something is opening up or down, right? And that part is not different from vertex form. But what you do have is you have two new letters. You have the B and the C. Now, the B value is the coefficient of your x, where A is the coefficient of your x squared. Your C value, right here, is actually your Y-intercept. So the way that you find your Y-intercept is super easy. It's just 0, whatever your C value is. So it's your C value. To find your axis of symmetry, you're going to need both your B and your A value, and you plug it into this formula right here. Let me make that a little bit wider. There we go. So plug your values in. And then simplify. Now, in order to find the vertex, what you're going to need to do, okay, you're going to use both the x equals negative b over 2a and your a and b and the entire equation, in fact. So what we're going to do is we are going to plug the axis of symmetry or your x value of the vertex into the entire equation. And then evaluate or simplify for y. Now, the way that you would see the vertex written out, by the way, it would look something like this. Your vertex, where your x value is negative b over 2a, and then it's f of negative b over 2a, meaning you've plugged in that vertex, the x value, into your entire equation. So let's go ahead and do some examples really quickly. First thing I'm going to do, as always, is I'm going to figure out what my a value is, what my b value is, and what my c value is. My a value in this case is 1. There is it's not an imaginary one. It's just the coefficient of that x squared. There's 1x squared there. My b value is negative 6. My c value is 5. By looking at the a value, I already know because it's positive, it's going to be opening upwards. If it's opening upwards, then this point right here, my vertex, is my minimum. There you go. You already answered 2 questions. And you already knew how to do this. The next one that I can do without doing any math is finding that y-intercept. My y-intercept is this right here. Let me keep with the same colors we had on the front. And you get 0, 5 as your y-intercept. It's just your c value. Right? Now, it's your axis of symmetry where you're going to need a little bit of work. Same with the vertex. So, in order to find your axis of symmetry, remember, you're going to use x equals negative b over 2a. All you're doing is plugging these values in. So, x equals negative 6 over 2, 1. Plug them in and always use those parentheses. So you get x is equal to 6 over 2, which means x is going to equal 3. That 3 gives you part of your vertex right here. And now what you're going to do is you're going to take this 3 and drop it in wherever there is an x. So you're going to get 3 squared minus 6 times 3 plus 5. Or in other words, 9 minus 18 plus 5. And that ends up giving you a negative 4. With that negative 4, you can tell me that your range is going to be greater than or equal to negative 4, because think about it, your a value is greater than or equal to 1, so it's greater than it. All right, so that's why you can get in. Now, your domain, for almost all parabolas, about 90% of the time, it's going to be the same thing, which is all real numbers. Now, here's the deal. When we're graphing this, we've got a couple of different points. We've got 0, 5. Okay, we've got our vertex down here of 3, -4. And we know that because our axis of symmetry is cutting through it. P.S. Because of this axis of symmetry, I could probably tell that there's a point right here too. 3 away from the axis of symmetry. But that's all I know. You want to get a couple of more points in here. So what I like to do is I'm going to put my vertex in the middle. And I go 2 above and 2 below. 2 x values before and 2 after. And then I plug it in. So I do 2 squared minus 6 times 2 plus 5. 1 squared minus 6 times 1 plus 5, and so forth and so forth. I want you to go ahead and pause the video, do that, and come back and check yours with mine. All right, so you should have gotten 0, -3, -4 was already there, -3, 0. And you'll notice, in fact, your vertex is right here, and right in your table, you're getting parabolas, essentially, with the values. Okay, they mirror each other because of that axis of symmetry. So if I were to give you just this table, you could tell me that the vertex was 3, -4, because that's the point where things start going the same in both directions. All right, so we're going to go ahead and plot these points. And we also find out that our solutions are 1 and 5. Oops. Hopefully yours is a little bit more U-shaped than mine is. All right, we're going to do one more. All right, so in this case, our A value is -2. Our B value is 12, and our C is -16. You know that it's going to open downwards because of the negative A value. And you also know that you're going to have a maximum since it's a frowny face. All right, now your axis of symmetry, your Y-intercept, and your vertex, and all of these fun things, you can figure these out with math, except for your Y-intercept. Your Y-intercept is given to you guys. Your Y-intercept in this case is 0, -16. Your axis of symmetry, you're going to use that formula, -b over 2a. Your B value is a 12. And your A value is a -2. So, simplify it, and you get -12 over -4, which is actually gets you 3 again. Cool. Plug that 3 in so you can find the Y value. And you're going to get -2 times 3 squared, which is 9, plus 12 times 3, which is 36, minus 16. When you add all of that together, you get 2. That means our range in this case is going to be less than or equal to 2. And as always, our domain is going to be all real numbers. Let's set up our table. Use our vertex as our middle point. 2, 1, 4, and 5. And now, since I know that it's going to parabola within my table as well, I can go ahead and plug in just 2 of the numbers and figure it out. So -2 times 1 squared plus 12 times 1 minus 16 gets you a -6. And then that means this is also going to be -6. -2 times 2 squared plus 12 times 2 minus 16 gets you 0. And there you go. So let's plot everything that we've got. 3, 2, our new points. And you'll remember that it's going really far out. And we couldn't even graph our y-intercept because of the vertical stretch that we had. And there you have it. All right, so I want you to remember the parent function. This is going to help you graph any single parabolic function that you're going to see. And you can graph anything using vertex form too now, because you're just moving this parent function along. And you can use this table to help you. So you'll recall that it's A equals 1, B is C, 0, and so is C. All right, so we know it's going to open upwards. We know it's going to have a minimum, and that means our axis of symmetry is going to be x equals 0. Our y-intercept is 0, 0. And if we were to not be able to figure out our axis of symmetry, it would be x equals negative b over 2a, which is really just 0. So you should have already been able to figure out that our y-intercept is also our vertex. So we can go ahead and set it up. 0, 0, negative 1, negative 2, 1, 2. When you plug it in, 1 squared is 1. Negative 1 squared is 1. Negative 2 squared is 4. And 2 squared is 4. Your domain is still going to be all real numbers. And your range for this is y is greater than or equal to 0 because of our y-intercept. I'm sorry, because of our vertex. So plot your point. You've got 0, 0, up 1, over 1. And then I go here, and I'm going over 2, up 4. And this is going to set me up for my parent function. And that's all I got for you. Thank you. Thanks for watching.